Here's 2017 question 5. It looks like a particle motion problem here. So here we go. There's a few subscripts, so people tend to get a little bit confused with that. This is x sub p of t, which is really just the position of particle p. So this is just the position of p. Right here, v is the velocity of q. Okay, so they tell you about two different particles. They give you some facts right here, but we'll talk about that later, okay? All right, part A is when is the particle moving to the left, okay? So the particle can either move to the left or to the right, but remember when velocity is positive, the particle will move towards the right. When velocity is negative, the particle will move towards the left. So what we're going to do is we're going to find our critical numbers here. Okay, so if you take a look at x sub t, now I won't write the p there. I'll just write natural log of t squared minus 2t plus 10. Okay, the derivative there, which is the velocity, okay? This is the velocity. That's going to be a chain rule here. It's going to be the derivative of the outside of the same inside times derivative of the inside, which is just 2t minus 2. Okay, so you could write it as 2t minus 2 all over t squared minus 2t plus 10. So our job is to make this velocity 0. So the way that you make a fraction go to 0 is you make the numerator equal to 0. And you could just tell by observation, or if you want to solve it, t comes out to 1. Okay, so when you do your sign chart, okay, let's pick 0 and 2. If you plug these in, you should, okay, so if you plug in 0 or 2 at the bottom in the denominator, you notice that it will always come out positive. Okay, so it only depends on the numerator here. So if you plug in 0 in the numerator, you get something negative. If you plug 2, okay, you'll get something positive. So pretty much from here to here is where the velocity is going to be negative, which implies that this is where the particle is moving towards the left. Okay, so we don't want to say from negative infinity to 1 because we're talking about time here. So it's going to start from 0 to 1. Okay, the particle is moving to the left. And there you go. Okay, here's part B. From 0 to 8, find all times where the two particles travel in the same direction. Okay, so from what we see so far with particle P here, okay, it travels to the left. I'll write it up here actually. Particle P from 0 all the way through will travel towards the left up until about 1, and right after 1 it travels towards the right always. Okay, so all that's left to figure out is, well, how is Q traveling? Right? Okay, so we already have the velocity of Q. It's v of t is equal to t squared minus 8t plus 15. Let's find some critical numbers here. That'll be t minus 3, t minus 5. So we know that the two critical numbers here are 3 and 5. Okay, so from 3 to 5, actually I'll scale this appropriately. From 3 to 5, we're going to check some values here, okay? So if I plug in, let's say 1 as my test value, if I plug in 1, I'm going to get something that's negative times a negative, which is a positive, okay? Which means it's going towards the right. If I pick something between 3 and 5, let's say 4, I'll get something positive times something's negative. So that means the particle is moving towards the left. If I pick 6, this whole thing is going to be positive, which means it's going to the right. So the question here is, when does particle P and Q travel in the same direction? Okay, so notice how Q and P start off going in opposite directions. Okay, but the moment at t equals 1, notice how, I'll highlight it here, notice how at t equals 1 and onwards, they start traveling to the right. Now, up until what point? They start traveling to the right. Now, P is always going to travel to the right, okay? But Q stops at 3, so we know that they're going to travel in the same direction from 1 to 3. Okay, is there anywhere else? Well, I know Q will always keep traveling to the right, and Q will travel all the way to the right starting at 5, so we know that they're going to travel in the same direction from 1 to 3 and from 5 to infinity. Okay? Here's part C. Find the acceleration of particle Q at t equals 2. Let's pause there. So we're looking at Q, not P. So if we have velocity and we want acceleration, we just take the derivative. So A sub Q of t would just be 2t minus 8. Okay? If we want to evaluate that at t equals 2, we're going to get 2 times 2 minus 8 equal, but I'm going to go a little bit further just for us to understand it. We're going to get negative 4, but more importantly, acceleration is negative, okay? Then they ask you, is the speed increasing, decreasing, or neither at t equals 2? So remember, if you want to know if the speed is increasing or decreasing, you have to check two things: the acceleration and the velocity at the same time. So I know that at A of 2, it comes out negative. So what's V of 2? Okay, so go ahead and plug in V of 2 there. You should get something, let's see, we got 2 squared, that's 4. 4 minus the 16 is negative 12, plus the 15 is something positive. Okay, so we know that they have opposite signs, so what does that mean? We know that the speed has to decrease, okay, since they share different signs. Make sure that you guys are explaining your reasoning there, okay? Here's the last one. Find the position of the particle the first time it changes directions. So we want to find the position of Q at the exact moment it changes direction. So let's go back to our sign chart here. So Q changes directions a couple of times, but we noticed that we want to focus on the first time it changes directions. So we know it's at t equals 3. Okay, so here we go. So if we have the velocity of Q and we want to go back to position, we know we have to integrate this. Okay, because if you integrate velocity, you go back to position. Now, we want to find the position exactly the first time it changes direction. So what we want is going to go up here. So in this case, t equals 3. Now at the bottom is what you're given. What fact are you given? I'll refer back to the part here. We're given at t equals 0. So you're going to put 0 here. But you have to consider where you are at t equals 0, which in this case is 5. Okay? So this is it. All right? You do have to continue and do this by hand. So here it's going to be 5 plus the integral of t squared minus 8t plus 15 dt from 0 to 3. So you do have to do this by hand. You integrate it, you should get t cubed over 3 minus 8t squared over 2 plus 15t from 0 to 3. The moment you plug in your upper minus your lower, you could stop there. So we'll have 3 cubed over 3 minus 8 times 3 squared over 2 plus 15 times 3. I'll group that entire thing. Minus 0 cubed over 3 minus 8 times 0 squared over 2 plus 15 times 0. I'm running out of space. But that's enough for equal is equal, and you're all done. Okay?